Introduction to NLP and Text Processing Techniques. Natural language processing is a branch of artificial intelligence that sits at the intersection of computer science, linguistics, and machine learning. Its main goal is to help computers read, interpret, and generate human language in a useful way. This is important because human language is complex. We use words with multiple meanings, incomplete sentences, slang, emotion, and context. For a computer, all of this is difficult to understand unless the language is carefully processed. In today's digital world, NLP is everywhere. Every time we use a chatbot, search engine, translation app, sentiment analysis tool, or voice assistant, NLP is working in the background. It helps systems process huge amounts of unstructured text such as emails, reviews, social media posts, articles, and messages. Without NLP, all of this text would remain raw data that computers could not easily analyze. Before a machine can understand text, the text must be converted into a structured format. This is where text processing begins. The first major step is tokenization. Tokenization means breaking a sentence or paragraph into smaller pieces, usually words or symbols. For example, the sentence, "NLP is powerful," can be split into the tokens, "NLP is," and "powerful." This simple step is the foundation for many NLP tasks. After tokenization comes normalization. Normalization is the process of making text consistent. This may include converting all letters to lowercase, removing punctuation, handling contractions, and correcting spelling variations. For instance, hello, hello, and hello should all be treated as the same word in many applications. Normalization helps reduce unnecessary differences in the data. Another important text processing technique is stop word removal. Stop words are common words like is, the, and, in. These words are often removed because they do not carry much meaning in tasks like search or classification. Removing them helps focus the analysis on more important words. Stemming and lemmatization are also widely used. Stemming reduces words to a root form, so words like running, runs, and ran may all be reduced to run. Lemmatization is similar, but it is more accurate because it considers the meaning and grammar of the word. For example, better can be reduced to good through lemmatization, which is more meaningful than simple stemming. These techniques help machines group similar words together and improve analysis. Once the text is cleaned, it must be represented in a form that machine learning systems can use. Computers do not understand words the way humans do, so text must be converted into numbers. One simple approach is the bag of words method, where the system counts how often each word appears. Another common method is TF-IDF, which gives more importance to words that are unique and informative in a document while reducing the weight of very common words. These representations help models process large collections of text. However, language is not just about individual words. Meaning depends on syntax and semantics. Syntax refers to the grammatical structure of a sentence. Semantics refers to the meaning behind the words. A word like bank can mean a financial institution or the side of a river, depending on context. This is one of the biggest challenges in NLP. Machines must learn not only what words are, but also how those words are used in different situations. This is why context is so important. Modern NLP systems are much better at understanding context than earlier systems. Instead of looking at words in isolation, they examine the surrounding words and even the full sentence or paragraph. This allows them to interpret meaning more accurately and handle ambiguity better. NLP has many real-world applications. One of the most common is sentiment analysis. Sentiment analysis identifies whether a piece of text expresses positive, negative, or neutral emotion. Businesses use this to analyze customer reviews, social media feedback, and survey responses. This helps them understand how people feel about a product, service, or brand. Another major application is machine translation. NLP powers tools that automatically translate text from one language to another. This has made communication across languages much easier and has opened access to global information for millions of people. Chatbots and virtual assistants are also built using NLP. These systems can understand user questions and provide responses in a conversational way. They are used in customer service, online shopping, healthcare support, and many other fields. Search engines also depend heavily on NLP. When you type a query, NLP helps the system understand what you mean, not just the exact words you used. Text summarization is another useful application. It allows long documents to be shortened into concise summaries while keeping the main ideas. This saves time and helps users quickly understand important information. Summarization is especially useful in business, education, law, and research. As NLP has evolved, more advanced techniques have emerged. Named Entity Recognition, or NER, identifies important entities in text such as people, organizations, locations, and dates. For example, in a news article, NER can automatically detect company names or cities. Part of speech tagging is another technique that labels each word by its grammatical role, such as noun, verb, adjective, or adverb. These techniques help systems better understand sentence structure. Word embeddings have also transformed NLP. Instead of representing words as simple counts, embeddings represent words as vectors in a mathematical space. Words with similar meanings are placed close together. This helps machines understand relationships between words. Even more powerful are contextual embeddings, which change depending on the sentence. This means the same word can have different representations based on how it is used. Modern NLP also relies on language modeling. A language model learns patterns in text and predicts what word is likely to come next. This is the basis for many advanced systems that can generate text, complete sentences, answer questions, and hold conversations. These models are trained on massive amounts of data and have become the core of many intelligent language applications. Another important area is text classification. Text classification assigns categories to documents. Examples include spam detection, topic labeling, and sentiment labeling. Clustering is similar, but instead of using predefined categories, it groups similar documents together automatically. This is useful when exploring large collections of text and discovering hidden patterns. Information extraction is another powerful NLP task. It involves pulling structured facts out of unstructured text. For example, a system can extract names, prices, dates, and locations from articles or reports. Information retrieval, on the other hand, focuses on finding the most relevant documents in response to a user query. Search engines are a perfect example of this. NLP is also used for emotion analysis. While basic sentiment analysis tells us whether text is positive or negative, emotion analysis goes deeper and detects emotions such as joy, anger, sadness, or surprise. This is helpful in marketing, social media monitoring, mental health tools, and customer service. One of the biggest breakthroughs in modern NLP has been transformer-based models. Unlike older systems that processed text one word at a time, transformers can look at the entire sentence or document at once. This helps them capture long-range relationships between words and understand context much better. These models have powered major advances in translation, summarization, question answering, and conversation systems. Question answering systems are another major achievement. These systems allow users to ask a question in natural language and receive a direct answer. Instead of searching through many pages of text, the system can find the exact information needed. This is useful in education, healthcare, customer support, and research. Dialogue systems and chatbots are becoming more advanced as well. They can now maintain context across multiple turns in a conversation, making interactions feel more natural. This has improved online support, virtual assistants, and interactive applications in many industries. Despite all this progress, NLP still faces many challenges. Language is full of ambiguity, sarcasm, idioms, and cultural differences. A sentence that seems simple to a human can be difficult for a machine to interpret correctly. Multilingual processing is another challenge because every language has its own grammar and structure. Low-resource languages, in particular, can be hard to support because there is less training data available. Bias is also a major concern in NLP. Since models learn from large datasets, they can absorb the biases present in those datasets. This makes fairness, transparency, and ethical AI very important in NLP research and development. Another challenge is explainability. Many advanced NLP models are powerful but difficult to interpret. Understanding why a model made a particular decision is still an active area of research. In healthcare, NLP is helping analyze medical records and support diagnosis. In finance, it is used for fraud detection and market analysis. In education, it powers tutoring systems and automated grading. In business, it improves customer support, market research, and content creation. The impact of NLP continues to grow every year. To conclude, natural language processing is the technology that allows machines to work with human language. Through text processing techniques like tokenization, normalization, stop word removal, stemming, lemmatization, and text representation, computers can turn raw text into meaningful information. NLP is not just about processing words. It is about helping machines understand meaning, context, and human intent. As the field continues to advance, it will play an even greater role in building smarter, more helpful, and more human-like AI systems.